Alrighty, well, we're all good to go. Thank you all for joining, and hello to everyone, and welcome to another instalment of Minnovare's Talking Tech series. My name is Campbell, and I'm looking forward to sharing an insightful and hopefully a really valuable show with you all today. Firstly, we'd like to thank you all for joining us today from wherever you are across the globe. It's great to see we have such a big audience from Asia Pacific and South America, as well as a heap of support from our friends over in Africa. And this is a favourite part of the world for us. And at the moment, we're really starting to increase our local staffing and dedicated support for the region. So thank you all for joining. Look, it's certainly fitting to have such a widespread audience here with us today, because the discussion topic, you know, it's a real major focus for many industries across the globe at the moment, and certainly for us as members of the global mining community. Now, understanding the impact of CO2 emissions on the environment is important for everyone to be aware of, so that we can prevent long-term issues and irreversible damage to our environment. And today we'll be discussing how we can reduce CO2 emissions in underground mining through optimised drilling. Today we have a special guest with us, Adam Gangemi. And Adam and his company, Supersmart Energy, specialise in providing solutions and actionable approach to climate change. And they do this through smarter and more sustainable mining methods. Now, we'll also jump into some real case examples with data that we've collected over the journey with some of our clients here in Australia. Please feel free to send through any questions you have via the webinar platform, and we'll do our best to respond to them all at the conclusion of the main presentation. I'll also be in touch with a number of you over emails in the next week or so with any direct questions that you may have. So please feel free to share and keep an eye out in your inboxes. So let's get this ball rolling. So introduction of myself, my name's Campbell Garrett. I am the Business Development Manager here for APAC and EMEA for Minnovare. And like I said, joining us is Adam Gangemi, the Managing Director for Supersmart Energy. Now, the focus and the outcome of today's webinar, and what we really want to hone in on, is understanding the emission reduction levers for your site. We want to see how you can utilise technology to avoid emissions. We would like to see how you can utilise, and through the work that we've been doing, our environment impact calculator, in particular for your site. And then we're going to run through some industry examples for CO2 emission savings from small to large gold miners. Before we dive into that, I just want to give a little bit of an overview of who we are. So Minnovare was formed in 2012 with our flagship product, the Azimuth Aligner. Now, what the Azimuth Aligner is, this is a solid-state gyrotech that we fix to the rail of your diamond drill rigs. What this helps to provide is azimuth and inclination and improve your overall accuracy in your exploration drilling. Now, we've managed to deploy in over 100 international mine sites over that journey. Now, we come through to 2008, and this is where the Production Optimiser came about. And this was actually due to the fact that we had a number of clients asking what we could do to provide solution to their blast hole deviation. And the production development of the Production Optimiser was actually in collaboration with two of our key clients through Evolution and Goldfields. Now, we fast forward through today, and in January 2022, Minnovare was actually acquired, and we've now joined a huge tech giant out there, and that is the Hexagon Group. I'll now hand on to Adam to introduce Supersmart Energy.
Yeah, thanks, Campbell. So, like Campbell said, we are a carbon and energy advisory, helping predominantly the mining industry to decarbonise their activities. Our consultancy and services focus on strategic net zero roadmaps and the implementation of solutions that are not only going to reduce carbon on site, but also improve operational and cost efficiencies. So let's click through. There we go. So I thought I might just kick off with, you know, what are the environmental challenges that the industry is facing at the moment? And typically we hear that the impact of climate change and the increasing rainfall and flooding and hotter days, and how that'll have an effect on operations. But I thought I'd go just a little bit deeper into the environmental challenges that we are seeing internally, so sort of within the four walls. So here are the four major ones here. The first one being just an understanding of the carbon emissions. You know, are we articulating our operational emissions, or are we going to be moving more into the value chain? So is it the direct emissions or the indirect emissions? And we'll go into that a little bit detail. Technology paralysis is huge at the moment, particularly around renewables. A lot of companies know that renewables from a cost perspective is leading. However, they're still waiting, that they're wanting to see what technology will do, if bifacial panels are the way of the future, etc. In regards to carbon pricing, how do we implement a carbon price internally? And finally, cost versus value when it comes to the solutions. So how do we have a discussion around cost versus value more often? If it's not daily, it's definitely weekly. There's a new news article that's saying decarbonisation is at the forefront of a particular miner, if it's in regards to net zero aspirations or collaboration. So we see here on the left-hand side, Andrew Forrest from FMG came out recently and said that they're going to spend $6.2 billion in order to get to their net zero ambitions, or the net zero target, and in doing so they'll save about 800 million a year. In the middle, we've seen large companies such as BHP, Rio and Vale come together to address the issue of charging for large electric haulage trucks. And then on the right-hand side, we've seen this big push in battery minerals. So BDO said earlier this year that there was about 2.4 billion pumped into pre-revenue explorers around these battery minerals. So this decarbonisation push is definitely here, and it's definitely being talked about on a daily, if not weekly basis. So just trying to get an understanding of where the underground emissions come from. So typically we see them from majority from your ventilation, about nearly half there, so about 42%. And then depending if you've got hoisting and other activities, you can see hoisting, drilling at 9%, transport to mill at 7%, then all the way down to blasting and crushing at about 1%. So, I guess we're starting to create a bit of a story here as to where we start to focus our energy to get some, bang for buck. And, those high single figures all the way through to the ventilation are ones that we really need to be focusing on. It's something that we do here annually is we create a gold industry benchmark. Other consultants do it as well. And what we do is we review the annual and sustainability reports of all the gold miners in Australia and produce this particular diagram that shows the greenhouse gas intensity for an ounce of gold produced. So on the very left-hand side is Bellevue with their aspirations at the moment to be the greenest gold company in Australia. And then we've got Boddington on the right there. But it's, there's a 7 times difference between, Bellevue to Newmont there on the right-hand side. But also, as the data continues to evolve, we'll be able to see companies that are moving closer to Bellevue, towards the left-hand side. But it's good to see, where you sit at the moment around your peers, and also how do we, help you move to the left. And I do note that, grade, and also there's also underground and open pit mines in here. But the objective is we're trying to help you move to the left-hand side without it being a big burden in regards to cost and operations. Might just dive into, and I hope that most of you are aware of, where your scope 1 and scope 2 and 3 emissions are coming from. I think in the intro we did mention about avoided emissions, which is considered a scope 4 emissions, but I'll just quickly run you through the different emission types, and hopefully that can just re-cement what you already know. So your scope 1 emissions are typically the direct emissions of the company. So if you think about company vehicles in regards to fuels, or company facilities in regards to oils, greases, gases used on site. Scope 2 is if you electricity used, and Scope 3 is your upstream and downstream activities. So in regards to business travel, in regards to getting goods on site, yeah, they fall under your Scope 3. So your Scope 4 is classified as your avoided emissions. So what products or technology are out there that can help you reduce your emissions that you currently have today, or in inverted commas, reduce those avoided emissions. So I guess, where do we go from here? Where should your first steps be in regards to data and automation? It's making sure you have a robust data capture system, particularly around fuel management. So we need to identify where your fuel is going and where it's being used. And if we can start to build those data systems that are capturing this data, it gives us some great insights into where to focus our attention on. An internal carbon price. So if you haven't done so already, companies are starting to basically tax themselves now. And what this is doing is creating a fund that they can draw upon for their decarbonisation activities. The third one there being more efficient equipment and biofuel. So is there a way that when we're looking to upgrade our equipment, can we look at one that's more, that ticks either a tier 4 or tier 5 fuel requirements? And in doing so, you're starting to see a lot of the fuel savings and in efficiency improvements, and as a result, reduction in carbon. Biofuel is an interesting one. A lot of companies are looking at it. If you even look at the aviation industry, they're looking at biofuels to support the industry there. With the increase in the diesel price, the difference between biofuel and diesel is getting closer and closer. It does cost a little bit more at the moment, but we can see in the future where it might meet parity, and it'll be an easier conversation than just saying, oh, we're able to reduce X amount of emissions. We'll be talking costs. And finally, renewables on site. So not only just integrating it into your power system, but can we put some redeployables around pumping and also around your lighting solution? So yeah, some real world examples. So Sandvik have been pushing their electric equipment recently. It is at a really small scale at the moment, but with time they'll start to increase production, and we'll start to see them on most sites going forward. And then the example from Goldfields on the left there from Agnew. So they've got a solar wind battery gas solution with a bit of diesel, and that's about 60 to 70% renewables penetration. Another example is the light vehicles. So a lot of companies are looking at transitioning out their current fleet to electric. We've seen, particularly here in Australia, a lot of the corporates are moving to Teslas and BYDs for their staff, particularly around the cities. However, on site, we're seeing companies such as Zero Automotive provide a solution where they are converting a 79 series Land Cruiser. So the 79 series Land Cruiser, mine spec's about $100,000, and then with the electric conversion kit is an extra $200,000, so it's about $300,000. You get somewhere around 200 kilometers range, and what we see typically from a ute, either whether it be a Hilux or a 70 series, the emission reduction per vehicle is about 3 tonnes, and that's confirmed via that first stop point from the Australian government site, the Green Vehicles Guide. So a Toyota Hilux 4x4, about 15,000 kilometres per year, it removes about consumes about 3 tons of carbon a year. So onto the Minnovare environmental impact calculator. So we got involved to QC not only the tech but the data side of things in regards to carbon. We wanted to, get a real understanding of how the carbon was being captured and QC it, and also then bring in some real world data to quantify what sort of savings either our customers or potential customers could use. So I'll go through on the next slide. There's a link through to the website for the calculator, but this is a tool that can help predict your avoided emissions per year and also identify potential production increase, and at the end of the day, getting some real bang for buck here. After you go through the process, you can send the report to yourself via email. But I guess overall, what this calculator is showing is if you actually can focus on less dilution by increasing efficiency and productivity, we are also going to reduce carbon on site as well. But I think that's enough from me talking through the presentation. Let me show you an example of the environmental impact calculator. So this is what it looks like. When you go to the home page, you need to go under resources and value calculator, and the environmental impact calculator sits under there. So I've just got an example here that a gold miner mined about 1 million tons last year and produced 223,000 ounces. So just some rough numbers. Let's estimate that the percentage of drilling due to reworks about 5%. Estimated ore dilution is around 20. I know because we've calculated this number that their tons of CO2 per ounce is 0.2627. Yeah, we'll just leave it as a narrow vein for this example. I'm just having some difficulties scrolling. So we're having some difficulties there. I'll just quickly put those in again.
One thing I will say while Adam is re-inputting those numbers is that, yeah, this is available online for free, complete use through our website. And yeah, we can provide a link to that post this discussion today.
Yeah, so we're back on. So thank you. I'm quite a conservative person, so let's just go say a 1% recovery improvement and dilution recovery of about 5%. So as we scroll down, you can see by putting those numbers in, and your numbers will change depending on your site. There's a avoided emissions of about 1,500 tons per year, and a additional gold produced of nearly 5,800 ounces annually. So really, in my opinion, really good bang for buck here in regards to the reducing the amount of carbon on site, and then as a bonus, you're getting additional revenue as well. I'll just go back to the web, everyone can see that okay?
Yep.
Yeah, okay, so I'll handle it. yeah, over to Campbell just to go through in a bit more detail about the product optimizer that they've got.
Thanks, Adam. I really appreciate that, mate. Thank you for the insight. That was really valuable. Can I just get you to press the arrow one more time? There's a little animation that'll pop up. So we're now going to look to focus on how Minnovare are looking to drive sustainable outcomes through our technology and what it is that we're currently delivering to the industry. So at Minnovare, we've specialised in improving the efficiency, the productivity, and the overall profitability of underground hard rock production drilling operations. And we've done this through a holistic and sustainable approach. And as you can see on the screen there, we've got 4 key antidotes to your waste, pollution, cost, and risk. Now, starting off with the risk, we look at the safety pillar. So what we do is, through the safety, we want to be mitigating your risks by introducing automation to your site. We then flip over and have a look at how we can improve your efficiency. And we improve your site's efficiency by reducing your waste as a result of increased drilling efficiency and accuracy. Now, as a part of that, you get a delivery in quality. So we want to make sure that we're delivering to site an improvement in your blast hole deviation, leading to less dilution and an increase in your overall quality of results with that reduction in waste ore. And then finally, you have your productivity gains as a part of this. And we want to make sure that we're increasing your productivity by making sure that you're drilling and doing it right the first time and not having to reutilize your assets a second or third time, depending on how your results are going. Now, the question is, how is the Production Optimiser solving the emissions challenges? Now, the Production Optimiser, this is a combination of advanced hardware and software with robust data analytics to substantially improve your drilling efficiency and productivity in your underground mines. Now, what we know is that blast hole deviation has its 3 main factors. You've got your in-hole deviation, your alignment error, and your collaring error. And throughout the journey and through the work that we've done in the industry, we know that on 60 to 70% on average of the issue actually occurs before you even drill the hole. Now, that's to say that 60 to 70% on average of the issue is actually caused due to your alignment and your collaring piece. Now, that is coming down to a factor of a stack up of error in the process, and especially in the current processes that are on site. So that can come down to 4 main factors. You have the rigs themselves. So you've got your slot wear and tear, your maintenance of the rigs, and how well they're operating. The next can be the survey. How accountable is survey for the work that they do, and how accountable are they for their markup as per the design? Again, another association of the rig is how well is that rig being leveled off in the drive, and is there potentially an inclination that wasn't accounted for in the design phase? And then lastly, and not to be taken lightly, is the operators themselves, and how accountable are the operators for the work that they do, and how accountable are they for their setup processes before drilling the hole? So it's this stack up of error in the process, and this combination is where the Production Optimiser comes in, and we make sure that we optimize your drilling practices and processes. And a benefit of this and what we deliver is you get faster soap cycle times. We give you a reduction in your dilution due to your accuracy increases. And then as part and parcel of that is increased ore recovery. Now, again, a little addition to the work that we do is that gives you significant savings on waste and energy consumption, and therefore overall will give you a reduction in your CO2 emissions for your site. Now, what we have here is a client case study that we did with Aries Resources out at the Krakow Gold Mine. For those who don't know, Krakow is located 500 kilometres northwest of Brisbane in Australia. Now, a little bit of background on this. The team at Krakow Gold Mine knew that they were facing challenges of dilution and stope performance due to their inaccurate drilling, which is what led them to come and approach us to help provide solution. The Production Optimiser is the solution that we implemented on site, and this case study was conducted in early 2018 in the narrow vein section of the mine. On to that next one. Now, for Aries Resources and at the Krakow Gold Mine, the key results that we were able to deliver during this case study period is they were able to really hone in on their drill design, and they were able to go from a DAS 5 down to a zipper pattern to be utilised on all of their stopes under 1.5 metres wide. Now, what that meant in turn is the site were actually able to unlock 119 stopes that were previously deemed uneconomical to drill. So in a dollar value sense, the deliverable there is they were able to unlock an additional $59 million of revenue over a 2-year period, which equates to $32 million worth of additional profit. And if you look at it from a productivity piece in regards to the additional ounces they unlocked, they were able to unlock 14,800 additional ounces. Now, when you tie that all together and you look at the fact that we were able to reduce their dilution factor by 62%, improve their stope turnover time, and actually allow for them to hone in on their drill design, they were able to avoid 8,552 tonnes, or a 17.5% reduction of their emissions per year. So on to the next slide, Adam. Now, what we have here, and this is what we highlighted at the start of the discussion, this is some industry examples for some lower to mid-tier mines, and I'll allow Adam to give you a bit of a run through of the assessment that we did here.
Yeah, thanks, Campbell. Again, you know, for me, it's all about the data, and looking at the Santa Barbara here, we're able to go to their sustainability reports and the annual report to get some inputs here. Recently I just went online and put the data in. So this here is the value calculator that sits on the Minnovare site. So I just put in, you know, approximate gold price in Australian dollars, put an estimate for the ore dilution and the cost of dilution, used again the 5% for the drilling due to rework, and then actually put the hard numbers in from the Gwalia gold mine. So you can see there 191,000 ounces, 727,000 total ore mined, and the current tonnes being of greenhouse gas intensity of, you know, 0.501. So again, being ultra conservative, putting in a 1% recovery and a 5% reduction in dilution, and what that spits out is, you know, taking your attention to the right hand side, and an emissions reduction of close to 2,500 tonnes a year, and an additional gold production of nearly 5,000 tonnes, and that was calculated to be, you know, nearly $9 million. So it was a significant result. Then I looked at another example, again on the left hand side, keeping the assumptions the same. This example was from Goldfields, from the Agnew gold mine, putting in the new production on the right hand side at 223,000 ounces, estimated total ore mine just over 1 million, and updating their greenhouse gas intensity to a 0.263, again being ultra conservative with the numbers, and then, you know, having a 1,500 tonne savings on carbon a year, whilst getting an increase in the gold production by, you know, nearly 5,800 ounces. So you know, it was for me, it was just I just wanted to quantify the carbon savings here with the dollar value, because at the end of the day, for us, you know, we've got a basket of solutions. So when we're having discussions with head of sustainability or a manager, we then go to speak to, you know, the CFO or the COO, and the first question they always ask us is either what's the cost and how much are we going to make from it, you know. And, you know, for me, I'd love for them to actually say it was, you know, what was the carbon that was saved, but unfortunately we're in a business of making money, so that they're the typical questions that are asked. I guess, Campbell, what's the, I don't know if you're allowed to say, but like the rough cost of a solution like this?
Yep. So for the Production Optimiser system, and we have a fairly stock standard pricing structure across the globe, but for here in Australia, the value of the contract over the period is around 293,000 over a 24-month term. So like you said, when you look at the value that can be delivered in not only the reduction in the CO2, but just the improvements that our system can provide, the cost benefit analysis looks fairly strong there. Yeah.
Okay. So that's equivalent to, you know, one of those EVs, the light vehicle EVs, yeah, about 300 grand.
Exactly right. And if you were to do a like-for-like comparison of the reduction in the CO2 tonnes for our system versus what the assumed tonnes for the EV is, I mean, it's a significantly larger impact that we're making, which is pretty positive to see.
Yeah.
Now, what we'll do is we'll jump into some questions. I know that we've had some be submitted online, but before we get into that, Adam, I've got a couple for yourself, and the first would be, you know, where is the best place to start on your decarbonisation journey?
Yeah, very cliche what I'm about to say, but it's so important to have a plan. And what I mean by this is, I'm not trying to create work for the consultancies out there, but what seems to happen is that you do your first decarbonisation or net zero plan, and it goes within and throughout the company, and then people come back and give you more ideas. And what happens is companies tend to then try and follow up all these different ideas, and they lose traction on where to start. So I'm saying, if you get your plan right and all agree that the first 2 years or the first 5 years, this is our focus, and just target there, and then update it in, you know, the 2 or 4 year period. And then as technology develops, you'll start to bring some other initiatives in. But yeah, get the plan done and then just commit to, all right, this is the first 2 years, is what we're focusing on. And then everyone's aligned and we're all working together. Otherwise, the plan goes in and then everyone starts to sort of fight for territory that, you know, they're wanting a initiative pushed in their department. Yeah,
of course. Well, that's actually probably a great segue for my second question. And that's, you know, what are the other short-term decarbonisation initiatives that you are seeing gaining traction out in the market at the moment that sites and you know, companies could really focus on?
Yeah, so in regards to underground, focusing on ventilation, you saw that from the graph I showed before was about 42% of the energy requirement is attributed to the ventilation. So a lot of companies are investigating on variable speed drives, so making sure that it's not at 100% capacity when they don't need all that air down there. Other examples in regards to decarbonisation first steps, lighting towers, putting solar lighting towers and converting their pumps to hybrids, so putting a battery solar solution. And then a lot of companies, particularly the bigger end of town, are focusing on sort of process optimization or just efficiencies on site. So they've got groups that are doing studies, etc., to focus on that while the electric hydrogen technologies develop.
Yeah, no, nice. I've just had a look on the panel. We don't seem to have any questions that have been sent through by anybody. So, I mean, if anyone does have a question, send it through pretty quickly. Otherwise, we'll be looking to wrap this one up. I'll give probably another 10 seconds. But again, thank you for your time today, mate. It's been really, really helpful. The insights that you gave and the feedback and the help that you've added to us, especially with the environmental impact calculator, has been immense. So we can't thank you enough for your support over this journey. I don't see any questions having come through during that period. So look,